my right hand a hammer. Where would be a better place to confirm his findings than on the moon? And so we thought we'd try it here for you, for our Falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Which proves that Mr. Galileo was correct in his findings.
Hi, I'm Ruta Kashiri, NASA Explorer Schools Coordinator in Langley, Virginia.
Hi, and I'm Rachel Power. I'm NASA Explorer Schools Coordinator from Kennedy Space Center. So Ruto, from that video, it looks like gravity really does exist on the moon.
Yes, Rachel, that's a great way for teachers to use NASA missions to teach physical science in the classrooms.
What other ways are teachers able to use NASA's missions, such as the moon, in order to inspire students and encourage them to study science, technology, engineering, and mathematics?
Rachel, we have a very special educator guide called Lunar Nautics, where the students will be designing a mission to live and work on the moon.
So if I was a teacher right now, I'd probably be wondering, what is Lunar Nautics?
Well, Lunar Nautics is an educator guide that helps students learn more about the moon exploration.
And what kind of activities, or what exactly would a teacher find in the activity guide?
Well, some of the activities that they will be going over in the educator guide is I will be designing and testing, analyzing, and managing science mission to the moon. And also, Lunar Nautics correlates to national science and mathematics standards.
So basically what you're telling me is we have different curriculum that's related to specific science and math standards. So what kind of expected outcomes should teachers predict?
Okay, one of the outcomes will be increased student ability to apply science, technology, engineering, mathematics, and geography concepts and skills in meaningful ways.
So it looks like students will also be conducting investigations.
That's true. Students will conduct investigations that will include investigation of data, results, and how the investigations relate to NASA.
So once our students start doing these activities, what kind of skills will they be practicing throughout the activities?
Some of the skills that the students will be participating in will be problem solving, team working, technological design, critical thinking, and communication.
These are all great skills, and these are skills that NASA uses throughout all of its missions, engineers, scientists, all the different cooperative groups working together to make a successful mission.
Correct.
So besides these skills, what other activities are we expected to find?
Well, the students will have an opportunity to do some design challenges, concept development, the moon, exploration of NASA, lunar missions.
What else?
And also they will design a mission patch, lunar lander, lunar miner, and a lunar base. And also they get a chance to develop a mission plan with a budget, learn how to come up with a budget and work within a budget.
So use some math skills as well.
Correct.
So there's all kinds of different design challenges and concepts involved. Can you list some of those design concepts?
Well, some of the design concepts will be rocket staging, balloon staging, pop bottle rocket, which a lot of teachers have done, lunar landing, swinging tray, lunar base, supply egg drop. And also there is rover race, spacesuit design, solar power, which is studying solar energy, microgravity, where they design a comeback bottle.
Now, that's a lot of different activities, but is that all that they'll find in the guide?
Actually, what we're only going to show them today, Newton's laws of motion. There are other activities which we'll highlight at the end of the program.
Okay, so we're going to probably focus today on just 3 main activities, because there's really so many different activities that we could choose from this guide.
Yes, today we're just basically going to show teachers how this guide is used for in the classrooms.